friends, this is Priyanka. Today we are going to solve a problem on oscillating roller follower having simple harmonic motion. In this video, we are going to draw the displacement diagram and cam profile for this oscillating roller follower. Now first, I will read what is the given problem. Draw a cam profile to drive an oscillating roller follower to the specifications given below. Follower to move outwards through an angular displacement 20 degree during the first 120 degree rotation of the cam. Follower to return to its initial position during next 120 degree rotation of cam. Follower to dwell during the next 120 degree of cam rotation. The distance between pivot center and roller center, which is equal to 120 mm. Distance between pivot center and cam axis is equal to 130 mm. Minimum radius of cam is equal to 40 mm. Radius of roller is equal to 10 mm. Inward and outward strokes takes place with simple harmonic motion. So this was the given question. Let us first understand the mechanism of the oscillating roller follower. Now if we observe this diagram, here one end of the bar is getting pivoted and this point is A1. And at the other end the roller is getting attached, that is here is the point A. So at the center point, that is at the pivoted point A, this bar is getting oscillated. So here the angle of oscillation is given and that is equal to 20 degree. So we can observe here this length is also given in the question, that is A1 to A, which is equal to 120 mm. Now we can convert this angle in the radians. So how to convert? So angular displacement of roller followers. So this displacement is 20 degree. That means initial position of the roller is at point A and after the displacement of this 20 degree, here is the final position, that is at point A2. So what is the total angle covered? That is 20 multiplied by pi by 180. That means this degree is getting converted into rad. So which is equal to pi by 9 rad. So this is the angular displacement in radians. Now when we are going to move the displacement diagram, then the stroke length is required. So how to calculate the stroke length? So during this oscillation, this movement of the roller from point A to A2 is known as the stroke length. So if we observe, this is the center A. So with the help of compass, if we observe about this center, here the point A is getting oscillated. So in this direction. So we have to find out what is the length of arc from this point A to A2. So we have formula. So what is the formula? That is radius of arc. So radius of arc is equal to length A1 to A multiplied by angle subtended by arc at the center in radians. So here angle subtended by arc. So this is the arc A to A2 and the angle is 20 degree. So we have to write this angle in terms of radians. So we have already calculated here. So we have to take here 120, that is the radius, multiplied by angle pi by 9. So when we calculate this, we will get the answer 41.88. Now here 120 is having unit millimeter. So our answer is also in millimeter. So this is the stroke length. So we have to take in the displacement diagram, stroke length is equal to 41.88 millimeter. Now with this information, we will move to draw the displacement diagram. So for one complete revolution of the cam, total angle is covered is equal to 360 degree. So we will take here some suitable scale. So we have to plot here one abscissa and on that abscissa we have to show the total angular displacement of the cam. So we will take here the scale is equal to 1 centimeter is equal to 10 degree. That means the total displacement 360 degree, we have to take this total length 36 centimeter. Now out of that 36 centimeter, that means out of 360 degree, first 120 degree angle is given as a outstroke then the next 120 degree angle given as a return stroke, and the remaining 120 degree angle given as a dwell. So here we have to take first 120 degree, that means as per this scale 12 centimeter distance for outstroke, 12 centimeter distance for return stroke, and the remaining 12 centimeter is for dwell. So in dwell there is no any movement, so I have minimized this length, and then on this ordinate, or we can say y axis, we have to take the stroke. So stroke length is equal to, we have calculated 41.88. So we have to plot this. Now the motion is given as a simple harmonic motion. So on the one end of this graph we have to draw one semicircle by taking the center of this total stroke length, and we have to make any number of even equal parts. So we can take 4 number of equal parts, 6 number, or 8 number. So we will take here 6 number of equal parts. So what is the total angle covered by semicircle? So it is equal to 180 degree. So we have to divide it by 6. So each angle is of 30 degree. So at a distance of 30 degree angle we have to select the point and we have to draw the line. So in this way there are total number of 6 equal parts. So we can give here the numbers also. So first, this is the first point, I will say 0. Then here first will be 1 double dash, 2 double dash, 3 double dash, 4 double dash, 5 double dash, and 6 double dash. Now this same number of equal parts we have to make for outstroke and return stroke. So we know that outstroke is for 120 degree. That means 120 divided by 6. So each part is equal to 20 degree, and 20 degree, that means 2 centimeter. So we have to select the point that is 2 centimeter apart for outstroke and return stroke. So here there are 6 number of equal parts are made. Now what is the next step? So next step we have to give here the number. So initial point is 0. Then here next point, that is 1, 2, 3, 4, 5, 6. So this is for the outstroke. Here is the 6, and that is the end point of the outstroke. And then for the return stroke, this line is the starting line of the return stroke. So here 6 and 6 dash. Then here is the 5 dash, 4 dash, 3 dash, 2 dash, 1 dash, and 0 dash. So these are the numbers. So remember, because here no any dwell period, so as outstroke is getting completed, at the same time return stroke is getting started. Now what is the next step? So next step, that we have to draw the horizontal lines from these points 1 double dash, 2 double dash, 3, 4, and 5 double dash from this semicircle. So I will draw here the horizontal lines. Now we have to select the points. Now if we select the points, first we will give here some letters. So at this initial point I will give the letter A. So this is the initial position of the roller. Now we have to take the point of intersection from this 1 double dash to 1, and in the outstroke, and for return stroke 1 double dash to 1 dash. So here after A I will give here letter B. So in the same way 2 double dash to 2, and 2 double dash to 2 dash. Then 3 double dash to 3, and 3 double dash to 3 dash. Then 4 double dash to 4, and 4 double dash to 4 dash. Then 5 double dash to 5, and here is the 5 dash, and here for 6 double dash to 6 and 6 dash. So this is the graph. So now we will give the letters. So these are the trace points. So I will give here first initial at point 0, there is the letter A, then B, C, D, E, F, G, H, I, J, K, L and here is M, that is at this 0 dash. So now we will connect all these points. Now after this return stroke there is the dwell period for total 120 degree. So we have to extend it because here the follower remains at rest. Now we will move to draw the cam profile. So for that the first step is to draw the base circle and the radius is given in the question, that is 40 mm. So take here O as a center and draw the circle with 40 mm radius and it is the base circle. Now the radius of roller is also given and this radius of roller is 10 mm. So base circle radius plus radius of roller is nothing but the radius of prime circle. So 40 plus 10, that is equal to 50. So we have to take O as a center and at a distance of 50 mm we have to draw one circle and this is the prime circle. Now we will draw one vertical line passing through the center O and this is the line in the form of dash. So we will draw here one line and the point of intersection for this vertical line with this prime center is the center of the roller. So here is the point of intersection. So we will consider this point will be the center of roller and this is the point that is the initial position of roller. So if we observe the displacement diagram, here is the initial position of roller at point A and number is 0. So we will consider here the center point A and at this 0 number we will draw one circle having radius 10 mm and this is nothing but the roller. So with the help of red marker we can see here the roller. Now if we observe the diagram, from the roller the pivot center is given at 120 mm. So how to select this pivot center A1? So if we observe the question, from this pivot center the axis of cam distance is also given and that is equal to 130 mm. So we have to take the compass. So in compass take 130 mm distance, take O as a center and mark one arc at a distance of 130 mm. And then in the same way take this A as a center and take 120 mm distance in the compass and mark one arc. So here if we mark the arc, this point of intersection is given is nothing but the pivot center A1. So here is the point A1 because this two distance is given, that is from pivot center to the axis of camshaft the distance is given and from this center of roller to the pivot center this distance is also mentioned in the question. So from this we have to take these 2 points are already getting selected. So we have to mark the arc from these 2 points and here the third point we will get. Now this is if we join this pivot center to the axis of the camshaft. So this is the initial position of the pivot center. Now this position remains constant because if we observe the movement of this oscillator roller, then this above this pivot center the roller is getting oscillated. So because this position remains constant, so again we will take O as a center and this we will draw one circle passing through this point A1. So if we draw this circle is known as pivot circle. Now if we observe the displacement diagram, here from the starting point there is the outstroke is for 120 degree and then there is the return stroke for the next 120 degree. So here is the initial position of the pivot, that is at this point A1, and if we join this O to A1, so from this line we will select the angle of 120 degree. So we will select here OA1 as a base. So if I select OA1 as a base, then mark the point at an angle of 120 degree. So here is the angle of 120 degree. So from this line I will draw passing through the selected point. And then again from this line we will again select the angle of 120 degree. So this O as a center, and again if I draw one angle, then here is the angle of 120 degree. So again passing through this point, selected point, I will draw one line. So these two angles are at 120 degree apart. Now as the 6 number of equal parts are made in the displacement diagram, so we have to make here the 6 number of equal parts. So again with the help of protractor, so 120 divided by 6. So each angle will be at of 20 degree. So here I will mark each angle at 20 degree apart. Then in the same way here also we have to make the angle of 20 degree. And now I will draw the line passing through the selected lines. Now we will give the numbers. So we have to give the numbers. So if we observe, as in the displacement diagram, we have to give the same sequence of numbers, because here the pivoted point is the fixed point, and about this point the roller is getting oscillated. So we have to give the numbers here. So first, this is the initial position, so we will give here the number 0. Then next number for the first partition, it is 1. Then here is number 2. Then 3, 4, 5, 6. Now this is the end point of the outstroke, and the same line is the starting point of the return stroke. So 6 and 6 dash. This is the same line for that 6 and 6 dash. Then next is 5 dash. Then 4 dash, 3 dash, 2 dash, 1 dash and 0 dash. If we observe the movement of oscillating roller follower, then here about the pivot center A, the movement of this roller from the initial position A to final position A2. That is, here the roller is getting oscillated, and here is the fixed center, that is the pivot center. So we can say that from this pivot center A, this distance A1 to A remains constant, and along this path A to A2 there is the movement of this roller. So what we have to show in this diagram, so if we observe all these numbers, that is the 1, 2, 3, 4, 5 and so on this pivot circle indicated the position of this pivot center, and which is fixed. So this position, so that there is the circle, that is pivot circle is having the uniform radius, and on this radius we have located all these points. That means this center is not moving anywhere, and the roller is moving, that is there is the displacement of the roller from the path A to A2, but here the distance in between this roller center and pivot center remains constant. So for that we have to take the distance A1 to A in the compass, and from each point on the pivot center we have to mark an arc. So arc that we have to mark from this prime circle. So if I take 1 as a center, then I have to take this distance A1 to A, take 1 as a center and mark here one arc. Then next step is 2 as a center, then mark here second arc. Then 3 as a center, mark here third arc. So this arc should start from the prime circle. Now I will give the numbers. So here from this point 1, this arc is marked here. So here is also 1. So from this point to here is second arc. Then 3, 4, 5, 6. So from this 6, so 6 is nothing but 6 dash also, because this is the starting of the return stroke also. Then again from 5 dash to here is 5 dash, 4 dash, 3 dash, 2 dash, 1 dash, and here is 0 dash. So all these are getting marked. So these are the numbers. Now we have to take the distance in the compass for the trace point. So if we observe from these numbers, these letters B, C, D, E are the trace points. So I will take the distance 1 to B. So if I take the distance 1 to B, then I have to take here 1 as a center and mark 1 point, and this is nothing but the point B. So this point B is the trace point and it is the center of the roller. Then the same distance is covered from this 1 dash to L. So here from this point 1 dash I have to mark here 1 point, and this point is L. Then in the same way I will take the distance from 2 to C. So from this 2 I will take here the center C. Then the same distance is covered 2 dash to K. So here from 2 dash I will mark here 1 point, that is K. Then next is 3 to D. So I have to take here the distance 3 to D. So same distance is covered 3 dash to Z. So from 3 to here is the point, that is D, and 3 dash to Z. So here from 3 dash I will mark here the point Z. And we have to repeat the procedure for the next points also. All these trace points are getting selected, that is A, B, C, D, E, F, G, H, I, J, K, L and M. Now taking these trace points as a center and the distance is equal to 10 mm, draw the circle. So with radius is equal to 10 mm, here all the circles are nothing but the rollers. Now if we join all the trace points, then we will get the pitch curve. So here with smooth curve we have to join the trace points. So in the form of dash I will join all the points, that is A to B, B to C, then C to D, then D to E. So curve should be smooth. Then here E to F, F to G, G to H, H to I to Z, then here is K, L, and last one is M. So this is the curve, and this curve is nothing but the pitch curve. Then how to draw the cam profile? So for that we have to join all the lower points of the roller. So here this is the lower point of the roller. Then for this trace point B I will join here the lower point. Then for C also, for D also. So curve should be smooth. So this curve with the help of black marker is nothing but the cam profile. So we can say that here this is the cam profile.